Welcome to Academic Daddy's class. Today we are going to be treating solubility. Solubility products, which we represent with KSP, and then ionic products. So when we talk about solubility, we simply refer to dissolving. Another name for soluble. When you say something is soluble, it means it can dissolve. Is the solution. So when we talk about solubility, we are talking about the amount of solutes that can dissolve, solutes that can dissolve in 100 gram of solvents. That's the first definition. Now another definition for solubility is simply the amount of solutes that can dissolve in a solvent to form a solution. Of course, you know that solute plus solvent gives you solution. To form a solution without precipitates. This is another way to define solubility. So we normally give the unit of solubility by mole per liter. If you don't write it like this, you can say it's the same thing as saying, this is the same thing as saying mole over liter. So notice it. Notice that this is talking about the mole of the solute, and this is talking about all over the solution. So you can put it this way. You can say it's the same thing as saying this is the standard unit, but in some books you see it as mole of solutes, gram of solutes all over gram of solvents. So we can also define, that means that we can also define solubility as the grams of solutes that can dissolve, in 100 gram of solvents. So if I know this is for solubility. If I say be soluble, I mean what it means is be dissolving or dissolve. Now let's move to this one, solubility product. Solubility product is different from solubility in the sense that solubility products KSP is only applied to electrolytes that are sparingly, or solids that are sparingly soluble in water or in solvents. So whenever we talk about solubility products, the first thing we are checking is, we know that if we add solutes into solvents, that solute into solvents on the solution, if it is able to form ionic products, the maximum number of ions that the solvent holds is what we refer to as ionic product. So we can say that ionic product, solubility product, is the maximum number of ions that a solution can hold. That is KSP. And we also say that this KSP is given by ionic products, that is the plus ion, ionic products, that is the metal ion, then products of the ionic product, that is metal and non-metallic ion. So ionic product, so minus. So let's say, for example, let's see what I mean. If I have A, B to be a solid, you know that it's either solid or liquid. So we know that gases, there cannot be in a situation where you are saying that it is getting to dissolve. So all of gases, they actually, should I say, move such that if you put it inside and say you want to come and be doing to form a solution with it, all gas molecules are solutions. So you don't come and put it in a place where you are checking if you can dissolve it. So that's what I mean by here. So when we are thinking of these aspects, these concepts, we focus on liquids and solids, and we say that this KSP can only be obtained when you've reached a point of saturation, or when the solution is saturated, such that you are adding and you can no longer add. We'll get to that, but just know that this will be a reversible reaction where I will have A plus and plus B minus. Now what we call this thing now is solubility equation. Solubility equation. Now the KSP equation will simply be AB in such a way that A plus comes here, then B minus comes here. So you can see that if I'm to find the KSP here, or if I'm to find the KSP, it will simply be by doing times these two. So let's say this is the solubility and this is the solubility. So when I do solubility square, I will get my KSP. Because at this point, this one that is here is going to be saturated. As I progress, I will show you what I mean. So even if it comes over, even if it comes under and say, let this be A plus B minus all over AB, KSP can only be gotten at the point of equilibrium, and equilibrium constant is K. So by the time this particular product that is a constant, now it has to be constant, it has to be concentrated, nothing can happen again. So for that reason, this constant come and multiply this crossover. When it's crossover, it becomes that KSP that you have, which is equals to everything here, A plus B minus. So I will after analyzing this, I will make out space so that I will explain this more using solute entering before it dissolves, so you get it better. So now for ionic products, ionic product is simply, remember, solubility product is the maximum number of ions that solution can hold, which means that KSP depends on amount of solutes and solvents. So which means if the solvent can no longer take solutes, that becomes the highest point, or if you, the maximum. Whatever ions is in that solution that time is determined because of the fact that it's reached saturation. You can no longer dissolve anything. I told you saturated solution is that solution that can no longer take, or should I say, a solution which can no longer dissolve more solutes in a solvent. Or when you say a solution which has reached the point where addition of solutes no longer creates the solution in the solvent. So for ionic product, we simply say that ionic product is simply the number of ions in a solvent. That is what ionic product is. So number of ions in a solvent. So now that you know this, in our next class, what I'll be teaching you is how to obtain this solubility, like practical aspect of obtaining this. So now you know what solubility is, you know what solubility product is, and you know that ionic product is simply, just like in this case, I have plus ion, I have negative ion. So I have one metal ion, I have one non-metallic ion. That is the number of ions. So that is ionic product. So if ionic product is greater than KSP, we will see what it will give us in the next video. If ionic product is equals to KSP, we'll see what it will give us. And if ionic product is less than ksp. In our next video, we'll see what it will give us. So please like, share, and subscribe.